Welcome back to the channel. Today I'm super excited because today we're going to be opening and reviewing the Amstrad PC1512. So if you watch my video about the PCMM, you'll know that the Amstrad PC1512 is my favourite computer of the 1980s, and possibly even the whole of the 20th century. But I've already got one, which is fully working, and just a couple of days ago I picked the second one up. And the reason I picked this up is because A, it was a reasonable price for what it was, B, it comes boxed, and C, it even comes with the Amstrad printer. This is a setup I had when I was 18 years old. It is a great little nostalgia trip for me. I'm very excited to be getting back into opening this from the scratch, from the boxes. I've got no idea what's in there. I do know it's not working. I do know the screen comes on, and with the Amstrad PC1512 that's important because the screen powers everything. So if the screen doesn't come on, then you've got a big problem. What I'm hoping is that it's probably more of a problem with the floppy drives or any kind of add-in cards or anything that's been put into this system. So let's get unboxing, let's have a look and see what we can do about this very lovely system from Amstrad. So what exactly have we got? We've got an Amstrad PC1512. This is the DD version. So this should have two 5.25 inch floppy disk drives, a 360 variant. There should be a keyboard, system unit and a mouse and some software in here. Now, he did say he didn't think the mouse was in here. So that's a little bit disappointing, but that's okay. I have another mouse I can use. They often get lost, as do the keyboards. The box itself is very dusty, but actually it's in pretty good condition. It's had packing tape on it to repair it at some point, or maybe that's the original packing tape. No other identifiers. There's something down here. It's got a serial number, so it'll be interesting to see if the serial number matches inside and out. But otherwise, it's the typical Amstrad packaging, one colour, very boring brown box. A good way to save money. This one's from the small study, so this person obviously had more than one study, perhaps 3 or 4. But we're going to open this up. Okay, I can see straight away that the polys are in there as well, which is very unusual. This has obviously been quite well looked after. Plastic bag, I'm guessing that's for the keyboard. Box, that's where the mouse would have been. It does feel empty. Another plastic bag, also approximately keyboard size. And here, in its polystyrene, is the keyboard, very yellowed. They all sound very hollow, but they're actually quite nice to type on, these keyboards. Has it got the colour or the black and white logos, or the monochrome logo? It's got the monochrome logo on it, so I think that makes it an early one. Sticker on the back saying manufacturer's revision E. Also in polys is the main unit, so let's get that out next. I don't want to lift it by the polys in case I break them though. They're in such good condition. So here it is, the base unit with the twin floppies. These look like the original ones. Sometimes floppies got switched out and they had very slightly different handles. But this has got a matching pair of handles, so probably the original. It's a bit dusty, as to be expected. But the front plastic's in pretty good condition. Top's quite yellowed, particularly in the back right corner. The battery compartment doesn't have any corrosion in it, which is unusual. Quite often they do have a little bit of battery corrosion because they've been left with batteries in there. On this side, we've got the standard for Amstrad ports. We've got these two little catches here which hold the keyboard cable in place because it runs along the side and then plugs in this hole here. And it was specific to Amstrad. And allegedly they did that because they didn't want to get sued by IBM. They'd already reverse engineered a BIOS, but they were worried that other ports might have IP associated with them, so they came up with their own mouse and keyboard system for this unit. It's unusual in that it's got a volume control for the built-in PC speaker, which is just here. Around the back, we've got, again, the standard ports for this one. There's no extra hacking been involved in making extra holes in the case. So basically you've got this input port here, which comes from the monitor to power the base unit, and then you've got the video out. And this is basically CGA, but it doesn't use a CGA connector, and it does have a slightly different timing signal to normal CGA. Then you've got a parallel and a serial port, and the serial port is a 25 pin, not a 9 pin. Here's the serial number, 535-6Y21043. And I've just confirmed that is the serial number on the box, so this is a matching pair, so that's great. Around this side, again, it's more yellowed on this side, probably closer to a window or a heat source. But it's in good condition, there's no cracks in the plastic. We've got both the covers in place, they're not lost. and overall looks in pretty good condition. All 4 feet are in place, and there's no weird marks or suggestions that it's had a water spill. So I've been a little bit lucky before when I bought Amstrad PC1512s and 1640s. Quite often there's been a hard card in the ISA slots here. On this one, the unit's a bit too light to have anything in there, but let's just open it up and have a look. So yeah, so that's empty in there. Just going to show you this because quite often this RF shield is very, very rusty on examples I've seen before. This is probably the least rusted one I've seen. It has got a little bit of corrosion on it, but it's not very bad at all. It's got the side door intact as well. It comes off, and it's got all its screws present. So I don't think anything ever has been installed in this expansion area. Cool. Do we take it apart or do we switch it on first? Let's plug it all in and switch it on. So the construction, by the way, is completely plastic. There is no metal frame in here or anything like that. It is entirely plastic, and unlike a lot of other plastics, despite being built to a price, the plastics are weared really well. They very rarely crack or break. Sometimes they chip a little bit and sometimes bits get lost, but I've never seen a 1512 where the case is damaged purely from handling or from disassembly. Usually it requires quite a significant knock. It's not unusual for twin drive models to have one of these replaced by a 3.5-inch 720k drive. You can use those in these systems. You can't use a 1.44 megabytes. The drive controller isn't quite fast enough to support those. So this one, the fact that it hasn't been upgraded, is nice in its original condition. This particular keyboard still has its polys, which is great. It's a little bit yellowed. In fact, it's a bit more brown than yellow. But looks like it should work okay. It doesn't look damaged. All the key caps are present. The back looks pretty clean. There's a bit of a smudge here. Still got both feet attached. So I'm hoping that's going to work. They usually do. I haven't come across one yet that doesn't. So that's good. The keyboard itself is a very standard XT layout. So you've got the function keys down the side rather than across the top. Separate numeric pad. Very large spacebar, not larger than average, I'd say. It's got indicator lights on the caps lock and the num lock. So it's, it's a fairly decent keyboard considering it was a budget computer. One of the weirdest things about it is that it's got this 9-pin joystick port on the back, which is wired in the Atari way. So you can plug just a standard joystick in here. It isn't a joystick port though in the PC sense. What happens is the computer translates the up, down, left, right motions into specific keys. So any game you can play with a keyboard, you can then allocate those keys to the joystick and you can use a joystick that way. If you plug in a sound card with a joy port, then obviously you can use your normal joysticks as well. But yeah, not a bad little keyboard. It's got this funny connector. Sometimes these get trodden on and get a little bit distorted out of shape. This one is perfect. And you can see what the colour was originally. It's quite a lot different. So here's the monitor. So the 1512 came with two different monitor options. It came with a CM Colour Monitor or MM monochrome monitor, and those are the only two options for this. The monochrome wasn't Hercules though. It wasn't high-res monochrome in that sense. It just was CGA, but with several shades of grey instead of colour. The monitors are lighter and obviously a bit simpler and therefore cheaper. So the base spec of this would have been with a black and white monochrome monitor and a single disk drive. And I think that started around £399 from memory. Adding a second drive added, having a colour monitor added, and I did do a later version of this that came with a hard drive as well in place of the second floppy disk drive. But in the very basic spec there was no hard drive on the Amstrad 1512s. Let's have a look at this box. It's in pretty good condition again. It's got, looks like the original packing tape on it. We have another serial number. Otherwise the box, pretty standard. It does have little handy holes for lifting which have not been pressed in, which is nice. Let's get the monitor out. Okay, so in the top of the monitor box are some floppy disks. So these aren't the original Amstrad ones, but they are copies of the original Amstrad ones. So you have Microsoft MS-DOS operating system on disk 1. Okay, also a few utilities in there like MVR. Disk 2 has Gem Startup on it. So Gem was a graphical environment manager. and it was an overlay on top of DOS, so you had to run DOS first, and that was very, very similar to Gem on the Atari ST, but aimed at the PC. Different versions of Gem. I can't remember which one this is. I think this might be version 2, which doesn't allow you to have overlapping windows. But I need to check that. Disk 3 is Gem Desktop. Okay, so Gem Startup loads all the libraries and stuff, and then Gem Desktop, you have to place that in the drive as well, and then you get the full Gem experience. It is version 2 by the looks of it. It came with Locomotive Basic, which was a Visual Basic, before Visual Basic, and not compilable, so it was interpreted, and it's a little bit slow, but at least it gives you the idea of how you could program graphical basic on a PC, which in 1987 was pretty clever. Final disk of these is DOS Plus startup disk. It's also got the Gem Paint app on it, which hopefully we'll get a chance to look at. DOS Plus is actually Digital Research DOS, and it was going to be the only operating system that was shipped with these originally, and the main reason for that was because it was available much cheaper than MS-DOS at the time. But when Microsoft saw the potential in this machine, they discounted heavily their version of MS-DOS, and so that's what ended up on Disk 1. But you do have the option of Digital Research DOS. So they're copies of the original discs. I do actually have a set of original discs, but it's nice to have these because when discs get this old, they sometimes stop working. I think these have been stored in pretty good condition. They don't feel dusty. The media looks pretty clean. So that's at the top of the monitor box. So again, the monitor has its original polys. Brilliant. So we have the monitor, very, very yellow, almost brown in fact, but hopefully functional. It is the Colour Monitor. No other labels on the front apart from the Amstrad labelling. It's just quite curved, you know, this is a very budget monitor. It's not a flat screen or anything. Hopefully it'll be working. Nothing very interesting on this side. The back's a little bit more interesting. So we have power lead, and then we have the two leads that go to the base unit. The larger one is the power, and the thinner one is the video signal. Proprietary way of, again, avoiding any lawsuits from IBM. It makes it a pain though, because this is the power supply for the main unit, so if you haven't got your monitor, you can't get the main unit to work, and this monitor you can't plug into any other computer either. Around the back here we have an on-off switch, which is hiding just underneath. Then we've got your horizontal hold and vertical hold, a load of air vents, manufacturer sticker with the serial number, and looking at that, it is the same serial number as on the box. Brilliant, another matching pair. On the left side we have the brightness and contrast dials. Far back on the right, basically you kind of reach around to switch it on with this plunger on-off switch and then adjust the brightness and contrast when it's warmed up. Great, let's assemble it. So there's this recess in the top of the Amstrad unit, and that's where the monitor stand goes. It's got a tilt swivel stand, and that just slots in there. We put 4 AA batteries in here if you want the real-time clock to be working. Let's just put the monitor on for now. Because of that recess, it makes it quite a compact unit as a whole. It's not very big by PC standards. For 1987, it's about half the volume of a 5150, for example. Got a very skinny, presumably 2-lead power cable that comes with a plug. Then we've got the chunkier cable that goes from the monitor into the back of the unit. And they do have little indicators on them to tell you which way up they should be. Second one is the smaller video connector. That goes into the right hand side. And again, that's a little mark on it to tell you which way up to go. Okay, and that's basically it. As far as the keyboard goes, that's got the round connector. This doesn't have an indicator on it to tell you which way around it is. On the outside, it does have a little notch on the metal barrel bit, and that goes in here at the top. And then you'd plug your mouse into here. So let's plug it in and see what happens, see if we get any smoke, any pops, bangs. Nothing so far. So we're going to turn it on. Power button's at the back of the monitor on that side. What should happen is it should beep. We should get power light come on, and then we should get the drives seeking. It's going to complain that there's no batteries in there. That's all normal behavior. Let's see if we get to normal behavior. The other thing to point out is they're completely silent. There's no fan in the 1512. Okay, so we're getting power light, and the A drive, which is on the left in this case, is seeking, but there's nothing on the screen. And that could be because we need to adjust the brightness and the contrast. Okay, so we do actually have something on the screen now. So error, faulty floppy disk controller or disk drive. So the floppy disk light is still on, and it's detected an error with the floppy disk drive. Okay, now that isn't necessarily the end of the world. It doesn't mean everything's broken. We've proved the monitors come on. It's not super bright, but it has come on. We've got power to the system unit, but obviously there's something wrong on the floppy disk controller side. Now it could be the controller itself, in which case it was a problem because everything's integrated into the motherboard. If it's the floppy drive, then there's ways of dealing with that. As you can see, power light's on, but the floppy disk seek light hasn't gone out. So what we're going to do is disassemble it again, take the system unit apart, find out if it's something as simple as a damaged or loose cable. If not, we'll try and resolve the floppy disk issue. Okay, taking one of these apart is very, very easy. You basically just take off the two plastic covers. You've got 4 screws holding the top and bottom cases together. Indirectly, the 3 screws that are holding the ISA cards in place also hold the case together, so they need to come out as well. So let's do those first. Sorry about the lighting, let's see if we can get some better light in here. That's a little better. Still not perfect. This metal bracket is then loose, and then you can pull it this way and the 2 halves separate. Let's get this rear screw out. So there's another screw here at the back. And then there's 2 screws at the front, and these are hidden by plastic covers normally. Sometimes they get lost. You just need something to get underneath them to pop them out. And then that reveals 2 more screws. And the 4 screws that hold the corners together are all the same size. And they're a different size to the 3 screws that hold ISA cards in place. So the top cover and the bottom cover now are essentially loose. They come apart, but there's 3 things to bear in mind. One is you have to loosen this metal bracket. Second is there's a wire that goes from the battery compartment down to the motherboard. And then the third thing is that this front piece is kind of helping to hold the 2 pieces together. So to loosen it from the back first. Sorry about the horrible squeaky noise. There we go. And here's the wire for the battery compartment. So this one has never been taken apart before. And you can tell because the blue wire goes through a little clip on the back of the drive cage, and that's still intact. So we'll unplug it from the motherboard and just get it to come out of its little holder, and then you can lift the top away. Inside the layout is very simple. Because there's no power supply in here, you've basically got 2 drive cages at the front, an RF shield over this half of the motherboard, a speaker down this side, and everything else is underneath. In terms of getting to everything, it's fairly straightforward. There are 6 screws that hold the drives in place. There's 2 here, 2 in the middle, and 2 on this side. And essentially 1 drive cage is on top of the other. In this case, it's drive A is on the top. I can't remember if that's how they are normally. You've got a power indicator light here, which has a connector on the board here. The PC speaker goes down to a connector near the front. What we're going to do for diagnosing is that the problem we've got is that one or both of these drives doesn't work, or the controller on the motherboard doesn't work. So, unlike a lot of computers, the floppy drive cable is soldered to the motherboard. It's not a removable cable. So basically we need to work at this end of the cable really, rather than at the motherboard end of the cable. So because it's never been opened before, I'm very happy with the cable. It's very good condition. I don't think there's going to be a problem specifically with the cable. The end nearest the motherboard appears to be intact. So it's very likely that it's the drives themselves, not the cable, or the motherboard controller. Because the motherboard's in such good condition, I don't think it's very likely that it will be the motherboard. It's much more likely to be the drive, I think. And the easy way to find out is just to disconnect them and see if it will boot without one or both. So let's do that. Let's also take the powers out in case there's a weird short and that's causing a problem. So now it's going to complain because it can't find a floppy drive, but at least that'll help narrow down the problem to the drives or the motherboard, hopefully. So now we have them side by side. Let's power them on and see what happens. So I've got a power light. It says please wait on the screen, which is the normal behavior. It's checking RAM at the moment. Faulty floppy disk controller or disk drive. So disconnecting the drives hasn't helped, but it hasn't now got a floppy drive to try and talk to anyway. So maybe it's complaining that there isn't a floppy drive at all. So let's plug one of them back in. So drive A, drive on the left, is now connected. Drive B is not. Okay, so we're still getting the same error and the drive has come on and is not going off. Let's connect to the other drive. Disconnecting the first one. See if we get similar behavior. So no light on the floppy drive. We're going straight to the error message. So the last thing to try is to put this drive onto cable A position. Now it won't reach because it's a custom cable, so we need to disconnect this drive from its housing and move it into this position so the cable will reach. Now because drive A cage is on top of drive B cage, we actually need to take both of them out. Amstrad long screws, strike again. So these screws all look pristine. The torques are about right for a system that hasn't had any work done on it at all. So I think I am the first person in here. So that's all of the screws out. 2 on this side, 2 in the middle, and 2 on the far side. So we should be able to just lift up the drives. Screws are in very awkward positions. It's actually quite hard to get the screws out independently, particularly the 2 in the middle. Because the screws go through the metal plate, they just don't come out very easily. There's one. This one I'm going to keep in because it's attached to an earth. This one has a little washer on it for cable organisation. This one should be straightforward. And then the 2 in the middle are the tricky ones. Let's get some pliers on that. There we go. So there's the drive in its housing. It's a very substantial housing. I actually think that's very over-engineered. They may have done it for RF shielding, I don't know, but it always struck me that this is probably one of the most expensive parts of the whole system. And drive 2, identical. So we can tell them apart. Drive 2, drive B has got the one with the little thing on the back, the cable management on the back. So let's try this in position A. Now, because the caddies are different, which again doesn't really strike me as being a very cost-efficient way of making them, this caddy won't sit on this side, it has to sit on that side. But we can just rest it in there and attach the cable, and then we'll see what happens. And then we get a faulty floppy disk controller. So basically it looks like it is the motherboard that's at fault here. So that requires a bit more disassembly to get to. Okay, let's have a go at getting this motherboard out. So again, we can tell this hasn't been taken apart before because to get the heat shield off, you need to undo these 2 clips so you can thread the cables through the holes in the motherboard, in the RF shield. You can also tell this is an early revision motherboard because it has the high number of spaces for your RAM upgrade. Later models only had about 1/3 of this number of sockets. So let's start by getting rid of these clips. You also need to take the volume control knob off to get the motherboard out, so we'll do that now. before I forget later. So on this side you've got the floppies, and on this side you've got the power. What we'll also do is unplug the power one and the speaker cable. And then there's a series of screws just around the outside and a few in the middle to remove the RF shield. A lot of them don't seem to be coming out. They're staying in the heat shield. They're not captive, they're just caught on the metal. From memory, these are all the same size, so it doesn't matter about keeping them in the right order. So I think that's all of them. Nope, this one under the floppy cable. There's this L-shaped bit that goes over the graphics port. It looks like this RF shield actually loops under, there we go. I thought it looped underneath the motherboard. So the RF shield's coming out. We get a first glimpse of the full motherboard. So the floppy drive connector cable is crimped here onto the board. It's not removable. Here's your system RAM, space for a RAM upgrade, CPU, ROM chips, various glue logic. I'm not sure which of these is the floppy disk controller, so we'll have to look at some product names. There's a little bit of corrosion over here by this crystal, but I think it's just the residual flux. Socket for the 8087 maths coprocessor if needed. A few of the chips are socketed, and this one over here with the Amstrad logo on it looks a little bit like it's come out of its socket. So one thing that's definitely going to be worth doing is reseating all these chips that are socketed first of all before we do anything else. Let's just do that. You probably heard that click back in. Right, it's probably made no difference at all, but let's just power it on and see what happens. It's a bit disconcerting that there are no noises from this machine when you turn it on. The one without the hard drive is totally silent. So we're getting a please wait message. Don't forget the speaker's disconnected, so we're not going to get a beep. Faulty floppy drive, disk controller or disk drive. So it's still not happy. Reseating that chip over there hasn't helped. So having done a bit of research, it looks like the floppy disk controller is this Zilog chip up here in the top left corner. It looks fine. It could be that there's a dry solder joint. I'm looking on the back side here, and a couple of the solder through holes are not particularly full of solder. So whether that's part of the problem. So what I'm going to do is take the board out, have a look at the underside of this Zilog chip, see if there's a problem, an obvious problem. In fact, looking even closer now, you can see it says FTC on it. So there's a good chance that's a floppy disk controller. So let's take the board out. So there should be a case of just lifting it up and pulling it towards us and slightly up on the right hand side, just because of these connectors on the left. There we go. So there's an RF shield in the bottom of the case, but we don't need the case now. So this is the chip we're interested in. None of the components around it look in poor shape. There's a few electrolytic capacitors up here in the top right corner. They all look fine. They're a bit bent over from where the RF shield has gone on. Let's turn the board over and have a look. So this is the area of the Zilog chip. So I'm just going to have a close look at all these under the microscope, see if I can see any problems with the solders. There seems to be quite a lot of flux left on the board. I don't think it was cleaned that well. So I don't have a proper technician's microscope, but if I'm having a quick look at these under magnification, I can't see any solder joints that are looking ropey. So that's good in a way. It could be the chip itself has failed. It could be that another component in the floppy disk controller system has failed. One of these two chips potentially, because it looks like these feed down through here and then into the floppy disk cable. When I was looking at part numbers, I was very surprised to find that most of these chips are actually still available to buy. Okay, so I don't think the BIOS is going to let us boot this system without a working floppy disk controller. But let's just put a hard disk controller in one of these ISA slots and see if we can bypass this error. I put the PCM in because The XT IDE that I've got, the actual connector seems about 0.5 millimeter too long for these particular slots. It just doesn't want to quite fit in, which is interesting. PicoMem's fitted in fine, but it was a snug fit. Let's turn it on and see what happens. So we've got power on the Pico board, so that's good. We're getting a please wait message on the screen. Will it allow us to bypass the floppy disk? No, so it's too unhappy about the floppy disk system to allow us to boot off a hard disk. So that's a bit of a shame. Okay, I've managed to get the XT IDE in just, it was a snug fit. Let's try that instead, because it's more of a hardware card rather than a software card. We'll see if that makes any difference in reality. No, still unhappy with the floppy disk controller. So having done some research, there are stories of failed components in this area. Capacitors, resistors, and these 1489 chips can be faulty, so could be that. One other anecdotal thing was that somebody said that if you don't have batteries connected and powering the NVR, that they can also get the same error. That's never been my experience, but let's just try it anyway. Faulty floppy disk controller still. So still getting the same error. That hasn't been helped by having a full set of CMOS batteries. So I've got a voltmeter, I don't have a logic probe, and I don't have a oscilloscope. So diagnosing exactly what the problem is in this corner is going to be a little bit tricky. So I've got a couple of different options. One is to get another complete working motherboard that I know is working, which is a possibility. And then once I've done that, I can then take this and play with it, and it doesn't matter if I break it, essentially, because my soldering skills aren't brilliant. But the other option is to get some other test equipment and then try and isolate the problem in this corner. So I think we'll have to call the end of the first video just there, because at the moment I don't have the tools to repair this and I don't have a replacement motherboard. There's two I have lined up, potentially new replacement motherboards, one's on eBay and other one's on Facebook Marketplace. So I may be able to just do a board swap. That feels a bit like cheating. I'd rather do it the proper way, but for the sake of getting videos out, I might have to just do that. Doing the other way requires me to get an oscilloscope and learn how to use that properly and then do some diagnostics. So that's going to be a several week process. So for expediency, I might just get a new board. So look out for part 2 coming up. We'll repair it, put it back together, get some software installed and have some fun. We're also going to check out the printer, obviously. So yeah, so sorry if that's disappointing ending to part 1. We will see you in part 2. Thanks for watching the channel. Don't forget to like and subscribe if you want to. You may be interested in these other videos that are on the screen at the moment.